Hello friends, this is Vidhan. Welcome you to my channel. Today we have a problem from June 2017, question number 41, booklet code B. It says a thermodynamic function G has been given as U minus Ts plus PV is given in terms of internal energy U, temperature T, entropy S, pressure P, volume V, and the number of particles N. Which of the following relations is true? In the following, mu is the chemical potential. So which relation is true? We need to find. This is G. G is what? Gives free energy. It is one of the thermodynamic potential energies. We know basically four thermodynamic potential energies are there. Internal energy, enthalpy, Helmholtz free energy, and Gibbs free energy. And we also know that for each potential, there are two relations possible, and each relation is a first order derivative. That means for internal energy, we have two relations. For the second potential, thermodynamic potential, enthalpy, we can derive two relations. Similarly, for Helmholtz free energy, which is F is equals to U minus Ts, for this also we can derive two relations. And similarly, for the fourth thermodynamic potential energy gives free energy, G, that is given by H minus Ts, for this also we can derive these two relations. Where one relation gives the volume, and volume is given by derivative of the Gibbs free energy or the rate of change of Gibbs free energy with respect to pressure under constant temperature, and the second relation is for entropy, and entropy is given by negative of the rate of change of Gibbs free energy with respect to temperature under constant pressure. That means from these four potentials we can derive these 8 relations, and these derivations have been given in one of my videos that has been named thermodynamic potentials. I have derived these relations from these potentials in this video, and you can refer to that for further detail. Now in this problem, since we are concerned with Gibbs free energy, so this is the Gibbs free energy, which is given by G is equals to H minus Ts, and these are the relations. Now one thing, in our problem it says that G is equals to U minus Ts plus PV, but here we can see that G is equals to H minus Ts. So if this expression is equal to this, then these two relations will hold, and we can directly compare these two relations with the options. That means if we find this one in any of our options, then this will be the right answer, or if we find this relation in any of the options, then that will be the right answer. But for that, this given expression for G should somehow be equivalent or equal to this. Now for that, let me write down the given expression. G is equals to U minus Ts plus PV. In our problem, it has been given G is equals to U minus Ts plus PV. Okay, let's write it here. G is equals to U minus Ts plus PV. This has been given in our problem. Now, is this equal to this? Then these two relations will hold. Now, let me do one thing. U plus PV, let us write it first, then minus Ts. Now, let me show you one thing. Now, see that H is equals to U plus PV. Enthalpy is equal to U plus PV. So, this U plus PV we can substitute by H minus Ts. So this part is H. That means we have G is equals to H minus Ts. And now you can see that this is similar to this. That means these two relations will hold, and we will compare. So we have two relations for entropy and one relation for volume and one relation for chemical potential. Let's check it. Now these two relations are for V and S. That means this entropy is the wrong option. For this thermodynamic function, which is equal to this, these two relations can be possible. So this mu cannot be possible. Let us check this V. Option 3. V is equals to minus del G by del P. Here we can see that V is equals to del G by del P at constant temperature, but it says negative of del G by del P at constant temperature. So this negative is missing here. That means this is the wrong answer. There should not be any negative, it should be positive. So it's a wrong. So 4 is wrong, 3 is wrong. Let's check for 2. Entropy is equals to del G by del T at constant pressure. But what is the reality? S is equals to negative of del G by del T with constant pressure at constant pressure. So there should be a negative sign, but here negative sign is missing. So 2 is the wrong answer. Let us check 1. S is equals to minus del G by del T at constant pressure. And we can see S is equals to minus del G by del T at constant pressure. It says at constant number of particles also, fixed number of particles. Obviously, it is also for the fixed number of particles. And so 1 is the right answer. So this relation is equal to this relation, and for this relation we can have these two. For this potential energy we can have those two relations, we can derive them, and out of the options this is the right option that matches with 1. So 1 is the right answer. So we have in our problem answer is 1. Thank you.